Welcome back. Today, we are looking at something, well, something truly massive. We're talking about these invisible atmospheric forces that are quite literally shaping our global economy and dictating the weather right outside your window. It's a phenomenon that starts way out in the middle of the Pacific Ocean, but eventually reaches right into our collective wallets. Okay, let's dive into this and decode the science and the honestly staggering economic stakes behind it.
Here's our quick roadmap for this explainer. 1. The ocean's climate twins. 2. The extreme weather of recent La Niña years. 3. The 2026 El Niño forecast. And 4. The multi-trillion-dollar economic fallout.
All right, starting off with Section 1, the ocean's climate twins. So to really understand this, we need to define the main engine, which is called the El Niño-Southern Oscillation cycle, or ENSO for short. You can think of ENSO like a massive global weather engine. Basically, it's a naturally occurring phenomenon where the ocean and the atmosphere in the Pacific deeply interact. Under normal conditions, trade winds blow warm water west toward Asia, and cold water rises up along the Americas. But ENSO completely breaks those normal conditions. It operates on this irregular 2 to 7 year cycle, and when it kicks in, it dramatically shifts weather patterns across the entire globe. Now, ENSO has two extreme phases, which we can kind of think of as climate twins. First, there's El Niño, which translates to little boy. During an El Niño, the trade winds weaken. The warm water that normally sits over near Asia gets pushed back east toward the Americas, and that normal upwelling of cold, nutrient-rich water just completely stops. On the flip side, we have La Niña, or little girl, and La Niña does the exact opposite. The trade winds kick into absolute overdrive, pushing even more warm water to the west, which causes intense cold water upwelling off the coast of the Americas. So they're exact opposites, right? But both of them trigger just extreme global disruptions. And this brilliantly illustrates exactly how that disruption travels around the world. What we're looking at here is the Walker circulation during a La Niña phase. You see that massive gray loop? That represents the atmospheric circulation. Because all that warm water is piled up in the western Pacific, the warm air rises right there, creating intense moisture, heavy cloud cover, and way higher chances of rain over places like Australia. Meanwhile, cooler air is descending over the eastern Pacific. This whole atmospheric loop is the exact mechanism that takes a localized ocean temperature anomaly and turns it into a massive global ripple effect. Moving into Section 2, the recent La Niña years and their multi-year extremes.
Normally, an ENSO event lasts, maybe 9 to 12 months. But sometimes they get stuck. A double-dip La Niña happens when La Niña conditions persist for 2 consecutive summers. Historically, about 50% of La Niñas actually result in a double dip. But a triple dip, meaning 3 consecutive summers, that is exceptionally rare. So why does this matter? Well, it's all about compounding extremes. Think about it. If you have extreme rainfall in year 1, your river catchments and your soil are completely saturated. If La Niña then returns for year 2 or 3, that new water has literally nowhere to go, which drastically increases the risk of catastrophic flooding.
Take a look at this data from the ENSO index. That dashed line right there is the threshold for a La Niña event. Look at that massive, undeniable blue-shaded area just dominating the chart from 2020 straight through into 2022. This wasn't just a quick passing weather event. This was a persistent, multi-year La Niña that completely dominated our climate and brought relentless, compounding moisture to the Western Pacific. And here is the direct, real-world result of that prolonged atmospheric pattern. We're looking at Australian rainfall deciles during that exact multi-year La Niña period. Notice those deep, dark blue areas on the eastern side? Those represent rainfall that is literally the highest on record. Because the catchments were already completely saturated from the prolonged La Niña, this atmospheric data directly translated into widespread, devastating flooding across entire regions. It's really a perfect, albeit terrifying, example of how ENSO directly shapes life on the ground.
All right, let's shift gears to Section 3, the 2026 El Niño forecast and the intensifying conditions we're seeing right now.
As of mid-June 2026, the sea surface temperature anomaly in the critical Niño 3.4 region, which is basically our key monitoring area in the Central Pacific, has climbed to plus 1.7 degrees Celsius. To put that into perspective for a second, anything above plus 0.5 degrees triggers an El Niño. So a plus 1.7 degree anomaly, that is massive. It signals that ocean conditions haven't just transitioned, they are rapidly intensifying toward a very strong El Niño event. And because of this intense warming, the latest outlooks are incredibly confident.
Forecasters have actually assigned a 100% probability for El Niño conditions to persist straight through the summer and fall seasons of 2026. I mean, there's absolutely zero doubt in the data right now. El Niño is here and it's locking in for the long haul.
So, the crucial point is the absolute consensus among our best predictive tools. Both the dynamical and statistical models are in total lockstep. Out of 24 participating models, all of them show strong agreement for this event. Even more concerning, 13 of those 24 models are projecting a very strong El Niño, and they expect it to peak in the fall of 2026 with temperature anomalies at or above plus 2.0 degrees Celsius. And this thing isn't fading quickly either. There is a 99% probability that this system persists right through the winter. But the thing is, the Pacific Ocean isn't acting alone here. We also have to look at the Indian Ocean Dipole, or the IOD, which basically measures sea surface temperature differences in the Indian Ocean. Right now, it's neutral. However, forecasting models show a 90% probability that it will shift into a positive phase by September 2026. And why is this important? Well, because when a positive IOD aligns with a strong El Niño, they actually act together as an amplifier. They intensify severe climate impacts, extending droughts in some areas while fueling massive storms in others. It's a huge compounding effect. Which brings us to our final section, Section 4, Trillions in Economic Fallout and the Global Cost of ENSO. Now, what's really interesting about this data is that we aren't just talking about local property damage from a passing storm. The research shows that El Niño persistently reduces global economic growth for years after the event. Just looking at the historical receipts, the 1982 to 1983 El Niño event caused an attributed $4.1 trillion in global income loss. The 1997 to 98 event, a massive $5.7 trillion. These climate disruptions ripple through agriculture, infrastructure, supply chains, and public health, basically creating a persistent drag on the entire global economy. And that brings us to what I think is the most jaw-dropping figure in this explainer. Looking ahead, an emission scenario consistent with our current mitigation pledges suggests that as the climate warms, it's actually going to increase ENSO amplitude and its global weather ripple effects. Because of this intensification, researchers project $84 trillion in 21st century economic losses. $84 trillion! I mean, that highlights just how incredibly sensitive our global economy is to climate variability, especially when human-caused warming amplifies that variability. Which leaves us with a pretty profound final thought. We've seen how just a few degrees of temperature shift in the Pacific can completely flip global weather on its head. We know a highly intense El Niño is locking in for 2026, and it's being amplified by shifts in the Indian Ocean. And we have the historical data proving that these events persistently erase trillions of dollars in global income. So the ultimate question we have to ask is, with an intensifying El Niño currently underway, is the global economy truly prepared for the trillions in fallout? Thank you so much for joining me on this explainer. I hope this sparked your curiosity, and I will catch you on the next deep dive.